Hello everyone. Today we're going to discuss the essentials about black holes. What are these strange things in the universe? How did they arise? And what even is the singularity? In general, stars tend to form when big clouds of stuff, hydrogen and helium in space, start to attract each other and get closer together. As they get really close, they start to undergo a process called the nuclear fusion. This nuclear reaction releases a lot of energy. This ends up pushing outwards on the new material falling in. Scientists like to call this balance of falling in and pushing out the hydrostatic equilibrium. So great, all is well, right? Well, not exactly. What happens when we run out of hydrogen and helium to mix this with? It turns out when this happens, the star falls in on itself. The core collapses. This collapse sets a huge bang in the universe known as a supernova. This explosion is violent and happens in less than a tenth of a second. What remains is a black hole, a super heavy, dense object. Just a note, this does not always happen. It's also possible that a core collapse results in a neutron star instead of a black hole or a white dwarf. But it does happen quite often. Well, what is a black hole then? It turns out a black hole is a big sphere or ball with a very heavy mass. It's characterized by something inside its center called a singularity. This is a point which tears the fabric of space and time. Formally, it's where space and time become infinite. It is infinitely dense, but infinitely small. Most of our theories, including Einstein's theory of general relativity, break down at this point. The scientific community has been pondering this for over 100 years since we first discovered general relativity, and we still don't have a real testable solution. Now, surrounding this singularity is a surface which looks like a sphere. This is what we call the event horizon. Anything which crosses the event horizon needs to go faster than the speed of light to escape it. This is simply not possible. So what happens when we fall towards the event horizon? How would it look like for someone traveling on a ship and for someone far away? Well, it turns out we can calculate this for an observer on a ship. The time needed to fall into the black hole can be calculated by solving the energy equation. I'm not going to derive this, and I'm also not going to solve this, but I'll write it out for you. The answer is given by the following equation. Here, we set R0 to be the location that we start at. Then, we have this in terms of the event horizon, which can be calculated using some fundamental constants and the mass of the black hole. This equation represents the total time taken to get from an arbitrary point in space, R0, right down to the singularity. This is the time that I would measure if I was on my ship, going from wherever I am at R0 down to the singularity. But what about the time my friend would measure? Would they measure the same thing? Here's where it gets interesting. If an observer were to look at me falling into a black hole, their time would not match mine. It would look like I'm slowing down as I reach the event horizon until I finally stop. According to someone far away, I would be frozen on the event horizon forever. Why? Time slows down when you experience an increase in gravity. The black hole is so dense, and it's so heavy that the gravity you experience slows your time down a lot. To your friend, you'll slow down to the point where you're frozen on the event horizon, and that's it. You will not be moving at all. And this is all caused by that one infinitely dense point, the singularity. Speaking about the singularity, it is so small that understanding it has really confused us as a scientific community for a very long time. We would need quantum mechanics to describe how it works. But here's the problem. Einstein's theory of relativity says nothing about quantum mechanics. Einstein himself said it's not possible. This is one of the mysteries of our universe. We just don't know how it behaves. And we, as a scientific community, have no testable explanation about this. Some believe that the singularity can be described as a little vibrating rubber band called a string. This is string theory, and it explains the absolute smallest workings of our universe. But the problem with that is that we haven't found a way to test it yet. So we're working on it. We've only just started discovering what a black hole is and what it can do, but already we know that there is a lot to learn from it.